Hello everyone, Rick Gurgis here again. On this particular video clip, I just want to recap quite a bit of what we've gone over in these other video series. So this is just going to be some quick setting slides, same slides out of the presentation I use at the actual Combine Clinic, but it's just going to be a set of quick things. What do I really got to know? What do I got to be able to do when I go to the field?
All right, we're going to start at the front of the machine here, and the very basic first thing we need to do is make sure we have our faceplate angle set correctly. Because again, the whole harvest operation stems about getting a nice even crop mat fed into the machine. So again, just double check your faceplate angle depending on which head you have on or what application you're going into. Okay, once we have our faceplate angle set, our next step is going to be get a good header calibration. And again, we've got some instructional videos on our Red Power website if you're any questions on how to do that. But want to make sure that header control is working properly for whichever head you have. Again, got to get started feeding the material into the head correctly or into the machine also. Another quick check we want to make is make sure that our feeder chain is tensioned properly. Here's a couple views. We have a couple different variations in the tension system depending on the age of your machine. But again, a good quick check before we go to the field is make sure that chain is tensioned properly, and that's going to help it feed in correctly and then also prevent any wrapping on the stripper bar at the rear. This is just a quick review on our feeder drum stops. This is the older variation where we only had 3 choices. When we went to 50 series, we're up to 4. We'll look at that in the next slide. But also important to know where those are at. Goes in conjunction with everything else of getting the material to feed in the machine correctly. So just be aware where you have your feeder drum stop set. And here we just have a quick shot of the newer 50 series and the 4-position feeder drum stop. Again, on the right side, there's the decal that's on the side of the feeder itself, so you can get an idea where you're at. And we always like to be in that position 4 with these, keep that drum as high as we can and allow the material in the machine better. Now we're looking at a shot of the rotor here, and again, we've gone over that in detail before, but one point I still want to make here is make sure for corn and soybean country that you have at least 4 straight bars on this rotor, as we've indicated in some of the other videos. So now we're moving kind of on into more of the threshing segment again. Just a reminder where we have 4 distinct different sections, kind of what's going on, where we're trying to get, of course, all the threshing complete in the front, get good start on separation, get the majority of it done up there, and then we're going to finish separation in the rear. And this all comes into play with our concave and basically grate selection system. This one's showing a 90-10. And that's probably very true in soybeans, but I would tend to guess once we get to corn, we're probably looking at more of a, maybe 75-25 area up there where we just got a lot more material, and it takes a while to get it all separated. And here we're tying into the previous slide with, again, which type of module we're going to put in there, whether we're round bar, large wire, and a couple variations of the round bars themselves. Went into that in more depth, but just again, be aware of what you have in there for the crop type that you're heading into. And here we have just a quick view of a good starting point, or good setup, I should say, for corn, where we've got 3 round bars surrounding that large wire that's in that number 1 right position. So here we just have a good overview of what makes a successful threshing. We got to look at several different things. We have rotor speed, of course, concave clearance, the configuration of the rotor, which we've already touched on. Vanes, again, we'll look at that here in a little bit as far as where we have them. But really the most common thing I've run into is when we have issue is running the rotor too slow. With these machines anymore, we need the centrifugal force of that rotor spin to get not only threshing complete, but to get separation complete. And that's where all the pieces of the puzzle kind of come together with everything on this list, is we need adequate rotor speed in order to achieve a good thresh and separation. And we've talked about that before. We'll get into a little more on our other slide coming up on actual machine settings. So here we're just looking at a shot of those veins we were just referring to in the previous slide. Veins, we're typically, what we're looking at here is the older system that we're mechanical adjust. We do have the newer in-cab adjust. But for these, typically, they were in the medium setting and we kind of left them there. They're not super easy to change. There are some incidents where it'd be nice to be able to switch them up a little bit, but for the most part, we've been in medium and we kind of make other adjustments to accommodate that. Um, Occasionally we get in some dry condition soybeans, and it'd be nice to advance the rear ones. Occasionally in corn, it'd be nice to slow them all down a little bit, but again, kind of a chore to change, so we just kind of run with where they're at. So here we have a quick view of our in-cab adjust or electrically adjustable vanes. One slight change is there's 8 vanes in total on this system, 6 that move, and actually 2 manual adjusts in the front. And again, on that previous slide, there were a total of 9 vanes on those that were all mechanical adjusts. So just a quick overview between those two. Settings of these, again, we can vary depending on whether we're in automation or whatever, a little bit more versus the mechanical adjusts. I will say, from my experience, that the material flows through the cage a little bit slower with the in-cab or these new style vanes. They are a lot thicker vane, cast iron versus old stainless steel ones. So it does seem like the material flows through the cage, has different characteristics. And I would just say in general, it's a little bit slower, which isn't all bad because we can make adjustments accordingly to work around that. So now we're moving back into our cleaning or sieve area. And one of my points I want to really keep hammering on, I guess, in a lot of these is we need a good sieve cal. Reason for this is if once we get to a settings area, if I suggest the top sieve needs to be at 20, we need to make sure that it is actually at 20. And again, there's a whole segment on sieves you can watch. This is just a quick overview again. But it's extremely important to know that you have your sieves caled so that the settings coordinate with what we suggest. Here's just a quick view if you have the in-cab sieve adjustment on the 50 series. It gives you an overview of what the button looks like. Again, on that cal, we have to open the sieve to a 1/4 inch or 6 mil opening before we actually complete the calibration process. And here we have just a view of the older system. Totally nothing wrong with this. Manual adjust, many machines out there with this system works fine as long as we know. Again, typically notch 3 was where we ran for beans, notch 4 in corn, but we have to make sure that on notch 3 we have about an 8 mil opening. And again, there's some adjustment on this. We can tweak this mechanically to get it where we need to. But again, extremely important to know where it's at to make the whole system work correctly. And here we have just a quick example of the sieve offset that we can put in the unit. And again, what I want to caution here is don't just automatically put sieve offset in because it sounds like a good idea. We typically need to verify through a crop loss or yield loss check that we do need that. I'm going to say typically in soybeans you don't need any. In corn, yes, we may need some, but we're going to be at a 0.5 to 1 positive to bring that right side up a little bit. Again, don't just put sieve offset in and assume it's going to help you because it can cause loss out the opposite side if we get carried away with it. And here's just a quick screenshot of where we go on the display to make adjustments to our sieve offset. And here's just a quick thought on our clean grain elevator speed. I've seen more and more problems lately of the elevator being set to slow speed when we're in corn. I do suggest switching it back and forth. I think things work better in beans, probably oats also when we're running on the low side. But in corn anymore, I think 100% of the time we need that elevator in high speed to make sure the clean grain auger and elevator are keeping the grain pan clean and we're not flooding that lower sieve or also increasing the risk of getting grain into the cleaning pan. So again, make sure you've got your elevator on high speed for corn. So now that we've made some just basic checks across the machine, now we're finally getting to what I call the basic settings that I would recommend for starting points. And we'll just start at the top of this chart that I put together myself. For corn, on that rotor speed, again, I say the minimum rotor speed is going to be in that 375 to 380 range in corn. I run into many cases where people are trying to run that rotor down 3 1/4, 350, and really that compounds a lot of problems because we have to step back and think, if that rotor is turning super slow, we're not pulling the material in out of the transition cone, and you just start back feeding the feeder back down into the head. So in corn, I think it is critical to maintain at least that 375 to 380, even in 15% corn, because then to throttle any type of crop damage or grain breakage or whatever, we're going to throttle it with a concave and open and close it until we get the performance from the rest of it that we need. So again, I am a big advocate of maintain rotor speed because it also affects machine throughput. And we can control everything else yet with that. As we get into vanes, they're going to be, again, mid. If we've got a 50 series, we can play around with that a little bit or let the automation do it. Precip is going to be at a notch 4, occasionally 5 if in really good corn. And then that's on the mechanical adjust, or that's going to be a 10 to 12 mil opening once we get into the in-cab adjustable. Upper sieve, typically in good corn, 20 to 22. Lower, 16 to 18. And a fan, a speed of 1,000 to 1,100. Historically, on my sieves, I always run the lower one about 2 numbers below the upper. So if my upper is at 20, my lower is going to be at 18. I think that balances out really well for the airflow going between them. As we move on into soybeans, we're going to be at a rotor speed of 6 to 700, and that could vary a little. Beans have such a moisture variance, for 9%ers versus 14s. Occasionally we'll get down to that 550 range on rotor speed, but this is good starting points. Concave 17 to 20, again, depending on the size of the head, how they're feeding in, how green they are. Veins net mid, maybe fast, depending again on moisture of the crop. Notch 3 on the mechanical adjust pre-sieve, or 8 on an in-cab, and typically we don't play around with that a lot. It's going to maintain that. Upper sieve, probably 15 to 17 range, maybe tweaking up to 18 in some really good beans. Lower sieve, 13, 15, again, that 2 number differential. And again, our fan's going to be in that 1,000 to 1,100 range. Kind of depends on what we have going on for crop mat moisture, I guess I'll call it, how dry the stems are. And then we're getting a lot more people running oats now. Ran with several of them this summer. And then these are some pretty good settings to start out with on oats. Usually at rotor speed 7 1/4, 750. Concave of 14 to 15 was working really well. Veins mid, maybe mid to slow. Notch 3 again, we're going to mimic our bean setting on that pre-sieve of a notch 3 or 8 with an in-cab. Upper sieve, we were running 14 to 15, and on this one, I had a little bigger differential. That lower sieve at 10 seemed to work really well. And then a fan speed of between 750 to 850, depending on the test weight of your oat and moisture and some other things like that. So this is what I have found as some really good starting points. I think if you set your machine here for any of these crops, you'll be really close. And then we can fine tune, again, for whatever particular conditions you might be running into. So once we've got our machine all set, we're running through the field, we do need to do some loss checks behind the machine to see how good of a job we're doing. So just some general ideas to keep in mind here of what we're looking for seeds per square foot to understand what kind of losses we're seeing. Corn, typically we're looking at 2 seeds per square foot. Now that's every square foot in an acre would equal a bushel. Soybeans, you're looking at that neighborhood of 5 seeds, possibly 6, depending on the size of the soybeans, but we'll just say 5 as an average. And again, that's seeds over every square foot of an acre to equal a bushel. So just some general guidelines there. So then we'll take a quick look next on how we're going to do this counting and figure this out. So here with my somewhat crude drawing I come up with, again, trying to establish how do we count to understand how much we're losing out of the machine. So again, it's maybe a touch hard to see here, but I've drawn out every square on here equals a foot behind the machine, or every square foot of the acre. So again, there could be 2 seeds in every one of these squares as we look across the back of the machine to understand what's going on. Of course, we have to look up, take a look up front. Are we losing any at the head, or do we have any pre-harvest losses from seed coming out for whatever reason? But just a quick overview, a little bit harder to get a good count with, we have the spreader in gear. So a lot of times I like to go into the windrow mode, and it kind of concentrates our loss behind the machine. We get a little better look or idea what we've got for losses. So here we have another one of my crude drawings, but basically here we're in the windrow mode. So we're going to concentrate our loss to, I don't know, 6-foot width or whatever we got right behind the machine. And it does help us, but we have to remember when we're counting in those squares, we have to take in account the width of our head and bring that across basically it's concentrated in that area. Now again, we've got to subtract out any maybe header loss we may be experiencing for whatever going on there. But if we take this down, into the smaller area, we're going to concentrate into the windrow width versus the 20-foot width of whatever this example was. So that would mean we could have 42 kernels in each one of the 12-inch windows right behind it in the windrow itself to equal a bushel, and this again in corn. So just kind of a quick overview of how we're going to look at this and understand what we really have for loss. I know a lot of times I'll get customer concerns about, well, I see loss and they're out looking in the stand in corn coming off the spreaders. Well, there is loss there, but it doesn't really tell us a lot because we don't know how much. We got to get into that windrow mode to understand really what we've got going on, and if we've got any grain walking out either the right or left of the sieve. So here's just some quick tips on automatic crop settings and automation, and when we are switching from one to the other. I just want to make sure this is clear. So when we're going from ACS and we want to turn automation on, that's fine. You can do that as you're running through the field. You reach up the headliner, grab the switch. The machine is going to grab your current settings, wherever you're at, and it's going to run with it from there. And the software in the automation is going to start making changes at that point. And that's fine. But in the other scenario, let's say, all right, I want to switch out of automation back to automatic crop settings. My suggestion on that is do that on a headland and cycle the separator on and off, because think of it this way. If we're running an automation, our machine settings could be quite different than what we have them established at in automatic crop settings. Once automation is turned off and you cycle the separator, the machine's going to say, okay, I'm going to go back to what we have in automatic crop settings and switch the settings on the machine, whether it be rotor speed, concave clearance, or whatever, and switch it back to wherever we're at for automatic crop settings. So just a quick tidbit of info on how to switch back and forth between the modes. All right, just a couple closing thoughts here. And again, I bring these points out at all my clinics. Here's one of your best friends, a good leaf blower, air compressor, whatever. Keep your machines cleaned off, and it will help you immensely on preventing thermal events. The more dry fodder we've got laying around the machines, more potential you have for lighting something up. As you know, time has gone on, our engines are running much hotter these days thanks to our emission systems. A lot bigger exhaust system hanging up there, just a lot more heat up in that engine bay area. So it doesn't take much to get dry fodder to light up sometimes. So again, I would highly suggest blow that machine off. If it's one of those really windy days with a tailwind, especially in corn, even at noontime, take the time to run around, get yourself turned in the wind so it doesn't quite such a messy job. Fan that machine off the best you can, and you might save yourself a lot of headache down the road. So here we are down to my favorite. Yes, it's a fun, fuzzy little critter, but oh my, can they create a lot of headache if they decide to take a nap in your fan shroud and you decide to start the combine up. Neither you or the cute little fuzzy critter are going to enjoy that. It's been particularly bad lately. The coon population has just gone crazy the last few years. And I don't know why, but that fan shroud is like a luxury bed for them. And I have seen so many times here, you fire that up, and before you know it, you are spending $7,500 and you are down a day or two with a new fan, shroud, radiator. They get really ugly sometimes depending on the size of your furry friend. So again, I highly recommend take the time to run up there before you turn on that key. Take a look around your engine bay area in general, and especially down that shroud. Make sure you don't have a companion there that's going to cause you a lot of headache. Hey, thanks everyone for watching. This brings us to the end of this video segment. I hope you found it to be beneficial. If you would like to see more in this video series, by all means go to the Red Power Team website, which is of course at redpowerteam.com. Navigate up to that video icon at the top, and from there it'll bring up the menu of the rest of the videos that you can watch, whichever ones you find interesting. Thank you.